Listen to the rain falling day by day. Listen to the rain falling day by day by day. Ah, hey.
Let's start small, molecule small. Let's start with an oxygen and two hydrogens. Link them with some covalent bonds. You got your basics of H2O structure. Let's add some more oxygens and some more hydrogens. Then link the hydrogens of one cluster to the oxygens of another with some hydrogen bonds. This gives you your basics for your mass of water. Now, in the world there's about 1.5 billion cubic kilometers of water. But after you take away the seawater, the glaciers, the ice caps, the groundwater that's too deep for us to reach, we're left with about 0.27%, which is useful for human consumption, which is not a lot. Well, it's not all doom and gloom. There's about 7 billion people in the world. That leaves us each with 146 million litres of water to drink each day. Of course, nature being nature, she does not spread this water around equally. Neither do humans live at equal distances away from each other to ease the water usage in certain places. Some places, like the guy on the top, well, he's obviously got far too much. You got urban sprawls, which, well, basically, they've got too little. Let's take a look at a place which has very little water. Cyprus, situated on the eastern Mediterranean, has its long hot summers and colder, shorter winters, with not enough rainfall to supply demand in many of the years. Let's call it the Cyprus problem. Surrounded by water, it's hard to think water would be in short supply. But as the poet Samuel Coleridge said, water, water everywhere, but not a drop to drink. This is certainly the case for Cyprus. Of course, the island has been split since 1974, which is a problem which very much hampers the water problems. With that in mind, let's call this the other Cyprus problem. It comes from a weather system brought in over the Mediterranean, which moves in a west to east direction over the island, giving about 300 millimeters per year on the west coast of the island, this rising to 1,000 millimeters per year on the summit of Troodos. It then goes through the rain-shadow effect and falls to about 250 millimeters along the plain. Then again it rises to 600 millimeters as it goes across the Pinalakos mountain range, and then dips due to another rain-shadow effect before heading back over to the east side of the island across the Mediterranean Sea. With the basics dealt with, it is important to note that most of the information used comes from the Cyprus Water Development Board, which is mostly concerned at this moment with the state of the water on the south side of the island, although the situation on the north is not far different. Here's a nice rain chart which shows the average rainfall in Cyprus. Just take note of the three yellow bars on the right hand side, as they are the dark years which cause so much trouble. Also notice the pattern of drought seems to be getting closer and closer between years. Also notice that the blue horizontal bar is getting lower. That represents the average rainfall. Both show a trend towards a more drier, less watery climate, which, as water supply goes, that's pretty much bad news. Cutting to the main figures, we have a total input of water of about 2,670 million cubic meters. 2,300 million of these cubic meters is thus through evapotranspiration, or evaporation, which leaves us about 370 million cubic meters to play with. The amount the island needs to get by is said to be around the region of 270 million cubic meters, leaving a surplus of about 100 million cubic meters, which sounds okay. They do lose 118 million cubic meters straight to the sea. They are also currently overpumping 29 million cubic meters from the groundwater, leaving an annual net loss of 47 million cubic meters. And if this is added to a drought, that just makes the situation even worse. Cyprus is basically a point of peak water, where the water they get from natural sources is just not enough to supply the demands of normal everyday life. How did it get this way? Well, here's a bit of land, and two bars. The first bar showing how much water a location naturally has, and the second bar showing a usage at any one given time. We'll start with a typical fishing hut near the sea, using minimal water. Then a few of the houses nearby pop up. As more houses are built, a school is needed. The houses then turn into apartments, then shops start to appear. The apartments then turn into a hotel. The old fishing hut gets turned into a nightclub. An airport is made up nearby, bringing an extra 3 million people in per year that visit Cyprus. And at that point, well, there's just not enough water. Of course, the government supports tourism. It brings in about 10% of the GDP for the country, and even during the worst droughts, when the local people were going through water cuts, the hotels were unaffected. They had their swimming pools, the water was flowing freely. If you think that's right or wrong, I'll leave it up to your own judgment. During the last drought, even the capital Nicosia was down to water just 3 times a week, and then for only 12 hours a day. Of course, when the water was flowing, people just would have took more than they needed anyway, which would have caused a bigger stress on the system. And those with more money, more affluent people, they just bought bigger water tanks, which would store more water for the days when the water wasn't running. So was it useful? Who knows? As you can see by the bars in the centre of this graph just how low the dam water got during the last drought. The average capacity alone is normally just 28% of what the actual dams could hold, so the water was about 5% of the whole capacity of the dam system. Dams are the greatest provider of natural water for Cyprus. There are 108 dams in Cyprus, making it the highest in the EU for dams per area, highlighting not only the importance of water that they provide, but also the limited number of other ways that Cyprus can provide water for itself. If full, the dams would supply 332 million cubic metres of water, but unfortunately the average they hold is about 92.3 million cubic metres of water, which means they're just running at 27.81% capacity. Here's an example of some of the dams. We have Pharmakos 1, which holds about 21,000 cubic metres of water, going up to Curious Dam, which is the largest, which holds 115,000 cubic metres of water. The nearby town of Olassos, had they been moved during this extension of this dam, the cost £5 million Cypriot pounds, which is about roughly the same as £4.5 million in English money. Although dams are good at what they do, the problem is dam science. The wrong and right type of rain can occur. What do I mean? Well, take a dam. Take some precipitation. If the rain falls in the dam, that's a boosty bonus. If there's overflow, through flow, any other kind of flow that reaches the dam from its catchment area, this is also good. If the rain falls a few metres outside this catchment area, no water for the dam, no water for the people. Wrong rain, wrong type. Dam science. The extraction of groundwater is always an easy fix in these drought situations. As you can see here, on the right hand side, this was the groundwater levels before the drought. Clearly good, clearly healthy. That middle one is during the drought, when they were heavily reliant on taking water from the ground, at very dangerous low levels there. And even now, you can still see that the aquifers are not back to their normal pre-drought levels. During the drought, the government had to take drastic action. The plan? Buy water from somewhere else. Greece came up with the goods. Cyprus paid €5 million for 8 million cubic metres of water. Of course, that was just for the water. Add on another €35 million for the shipping fees, and it's looking like a bit of a less deal already. Add to this, when the boats reached Cyprus, the port wasn't even ready to unload the water from the ships, which was a bit of an embarrassment to the government and a sign of the short-sightedness and the lack of direction which was prevalent at the time. But finally, the water was unloaded and some water got to the people. The final cost, astronomical. The water, €5 million, shipping fees, €35 million, paperwork, €1.5 million, in total, €41.5 million for 8 million cubic metres of water. Since then, it has invested in some desalination plants, which basically involves pumping seawater from the sea, processing it, and you get clean drinking water. The plus point, it's about €1 per cubic metre of water, compared to the €5 per cubic metre of water it costs to ship the water in. Of course, oil is used in the process, and the cost of the water is dependent upon the oil which is used. Also, the burning the oil gives off CO2, which leaves a kind of a catch-22 situation. More CO2, high temperatures, less water, more desalination plants, and of course, more CO2 again. It's just a vicious circle. In Cyprus, there is the osmosis type of desalination plants. Water is pumped in from the sea, first the organisms are destroyed, and the big solids removed. It then gets pre-chlorinated, acid is added to adjust the pH, and then it's filtered even further. It is then forced through the osmosis membrane, which lets nothing bigger through than 1 micron. It is worth bearing in mind it takes 2 cubic meters of seawater to make 1 cubic meter of fresh water, and the water which isn't used is flushed back out to sea. Of course, around the eye pipe this leads to a high saline water, but it is quickly dispersed into the local water, but is still an environmental issue. The best idea in the pipeline is probably a pipeline. The pipeline would run from Turkey to northern Cyprus, and said for the cost of water would be about 0.35 euros per cubic meter. One of the problems is, of course, the area has tectonic activity between northern Cyprus and Turkey, which is not very good for the health of a pipe that would run across it. Well, the idea? Easy. Put the pipeline suspended 250 meters below the water, supported by buoys. Problem solved. Water flowing. Great on paper, but of course, northern Cyprus, Turkey, Greece, southern Cyprus has a huge trust issue. Will it be done in the near future? Who knows? Of course, if the island was united into one, it would help a great deal, and they could start to build trust within Cyprus, and the pipeline maybe could be built. But for now, desalination is being used very heavily at a very high environmental cost. Urban recycle plants are starting to come online. Although they won't be used for drinking water, they are good for irrigation water, which will help reduce the stress on the natural water that is available for drinking water. But this is your problem. The government see the tourism as a big money spinner. They do all these separate things, build the desalination plants, start to bring urban wastewater on supply, and on the other hand, they start to build golf courses. A number of golf courses, of course, the irrigation of which is absolutely huge on the resource of water. It seems they get to the level which they cope, and then they just use more, just like a dog going round and round, chasing its tail.
That was God telling me everything's gonna be alright. We're so long, good friend. When will we meet again? I said so long, good friend. When will we meet again? Well, I don't know, but I guess I'ma see you then.